Hello, and welcome to the 741 channel. Thank you for stopping by. My friends at SDRplay have sent me their newest product for testing. This is the RSP1A software-defined receiver. So let's take it out of the package and see what we've got. So inside the package we have pretty much just the RSP1A itself. Here's a look at the product notes that are on the back of the liner that was in the package. You can pause the video here and read through this if you want to see some of the key specs of the RSP1A. So here's a look at the quick start guide that's printed on the inside of the liner. You can pause the video and read through this if you'd like to. So the SDRplay itself, as you can see, is just this plastic box. It's got an SMA connector on one end for the antenna, and it's got a USB connector on the other side for the USB connection to the computer. To connect to my antenna, I'm using this SMA to SO239 adapter that I purchased on Amazon. I'll leave a link to this in the description below in case you want to order one of these yourself. I'll connect the SMA connector to the RSP by just inserting it and screwing it on. And this can be a little fiddly, you want to make sure it's on straight. And then I'll connect up the SO239 end to my PL259 that's on the coax that leads out to my antenna. So now connecting the USB cable is simple. It's just plugging it there and then plugging it into the computer. But we don't want to plug it into the computer just yet. We're going to wait to do that until during the software installation when we're prompted to do that. But just a word on the USB cable itself. A lot of people like to run shielded USB cables, and in fact that's what I intended to do with this unit, but I accidentally ordered a non-shielded USB cable. Now it'll still work, and it'll work just fine, but some people feel that it's better to have the shielded cable to try and mitigate noise from your computer or other things in your house. The RSP unit itself has a shielded case. The inside of the case is coated with some sort of a metallic paint or coating to help kind of prevent that. And it just makes sense to carry that through and use a USB, or use a shielded USB cable rather, if you're able to. But for now, let's set the RSP1A aside and get started with installing SDRuno on the computer. So here's a quick look at the antenna that I'm using, for those of you who are curious about that. Now just for reference, my shack or radio location is down there underneath that extension sticking out behind the house, right where that cellar window is. And you can see the coax travels along the ground, or really under the ground a little bit, and then up here to this tree, and the center feed point of the antenna is right there. And it is just a homemade fan dipole with legs cut for 80 and 40 meters. So you can see there are two legs going off in that direction. There's one longer for 80 meter and one shorter for 40. And then of course we've got the opposing legs going off in this direction, a long one and a short one. And I don't know how readily apparent it is in the video, but from sort of the surface of the ground where the antenna is, it's about 15 feet up or so, but you may be able to tell that my lot kind of slopes down in that direction, so when you get down over there, it's actually more like, I don't know, 20 or 30 feet above the average terrain. So the first step in installing SDRuno is to navigate to the SDRplay website. Once we're at the SDRplay website, we'll go to the Start Here menu. The first page in the process has some information about the registration of the RSP1A and the software downloads. It also gives us this warning letting us know that we should not connect the RSP to an antenna that is also connected to a transmitter so that the unit is not damaged. The first thing that I'm going to do is choose my country, which of course is the United States. Next up, I'm going to choose my purchase location, which happens to be the SDRplay website. and then I'm going to choose Continue. So here on the second page, I'm going to choose my operating system, which happens to be Windows 10. But you can see that many other operating systems are also supported by the SDRplay devices. So now I'll click Continue. Next up, we have some pre-installation checks. The first one is to make sure that the RSP unit is not connected to the computer yet, and in my case it's not. Next up is the recommendation to temporarily disable your antivirus software, as it may interfere with the software installation. So once we've read and acknowledged these, we can check the box to move on. So now here we'll enter the pertinent information: name, email, and serial number. From the pull-down, I'm going to choose my serial number prefix, which is just the first 4 digits of the serial number. Next up, I'll type the rest of the serial number into this box. Once I've got that in, I can submit and continue. Next up, I'm going to choose which software package I want to use with my RSP1A. For the purposes of this video, I'm going to select SDRuno, but you can see that HD SDR and SDR console are supported here as well. Now, HD SDR and SDR console are both excellent programs and work well with the RSP, but personally I prefer the SDRuno package a little bit more than the others, at least for the SDRplay unit. This is the software that SDRplay has developed specifically for their products, and I feel that it works the best with them. So now that we've successfully registered the device, we can now click here to download the software. So now that brings us to a verification page, so we'll click this box down here to prove that we're not a robot. And now we'll have to answer this challenge puzzle by selecting all of the images with bicycles in them. And it looks like we passed the test, so now we should be able to start the download. Once SDRuno is finished downloading, you can just click down here on the lower left corner, and that should start the installation process. So you can see here we're going to allow the app to make changes to my device. I'm going to accept the agreement, and once again we're warned to make sure that no RSPs are connected to the computer at this time, so we'll abide by that and continue. I'm just going to accept the default program installation here, and again I'm going to accept this default folder. I'm going to let it create a desktop shortcut, and now I'll click install. So now at this point we're being prompted to finally connect the RSP to the computer, so I'll do that now. So I've connected my RSP to my computer, and I was waiting for it to install the drivers automatically, but I've realized that I've previously connected my old RSP1 to this computer in the past, so I think all the necessary drivers and everything are loaded already. But if this is the first time that you're connecting an RSP to your computer, you'll probably see it search for the correct drivers and whatnot down in the lower system tray. And you'll have to wait for that to finish and complete before you can continue on with the software installation. So now that the RSP is connected to the computer and the drivers for it should be installed, I'm going to click Next. So now we should be able to finish the installation, and I'm going to leave this box checked to launch SDRuno so that we can try it out. So as you can see, the application has started up and everything looks like it's working okay. Now the way this is laid out is there are various what I'll call window panes that control various functions or display things about the RSP. Up here in the left we have the main control pane, and this controls some of the main options of the RSP, including starting and stopping the audio. Up here in the top center of the screen we have the RX control, and this you could think of as the front panel of a traditional radio. This is where we can change frequencies, change modes, set the volume and squelch, things like that. Over here on the top right we have some extended options where we can set things like AGC levels, noise reduction levels, and notch filter settings. This pane over here in the middle left is for storing and recalling memory frequencies. This pane over here in the middle right is the extended spectrum display. This pretty much shows you a snapshot of the passband that you're currently listening to. And then down here, the lower half of the screen is the main spectrum display and waterfall display. As we use the RSP, we're going to end up jumping back and forth between some of these panes, as some of these settings are kind of interdependent with each other. So this is pretty much the default window layout that SDRuno gives us after its initial install. And I kind of like the way this is arranged, because all of the options that we'd kind of use to control the radio are along the top here, and then sort of over here in the middle and at the bottom are the waterfall displays and spectrum displays that we'll use to see the signals that we're tuning in and kind of fine-tune things. So I think this layout works well. However, if you want to move the windows around, you can. You can just grab each window frame and kind of click and drag it and position it however you want, and you can even resize them if you want to do that. There's a button up here in the top left of the main control window that controls whether or not these panes stay linked together when you do things like minimize or maximize or close them out. So right now the button is activated, and you can tell that because the text in it is orange. If I disable it, you can see it turns white. I'm going to leave it enabled, and you can see that if I minimize any of these windows, the whole application minimizes all at once. And I can bring it back up the same way. If I click on any of these windows, it brings them all back up onto the main desktop. However, if I turn that off, you can see that if I minimize any of the subpanes, just that particular subpane minimizes at that time. SDRuno gives us an easy way to go back to sort of the factory default settings if that's what you want to do. And to do that, we just go under the options button here in the top left of the main window, and we just go to reset default settings. So then a pop-up comes up to verify that we want to do that. I'm going to hit yes. SDRuno closes, and then I'll just reopen it. And you can see it's right back where it was when we first installed everything. So now you can see that I've closed all of the sub windows and I just have the main window up. If you want to bring back those windows or just bring back some of them, you can bring them back by clicking on these buttons up here in the top left corner of the main window. SP1 brings back the main spectrum display. SP2 brings back the auxiliary spectrum display. RX brings back the main RX panel of the radio. And then memory panel brings back the memory panel down here. If we want to bring back the extended options panel, we have to click on this button up here. And now we're right back where we started from. These two buttons here control the available bandwidth that we're listening to at any given time. So right now you can see we're set to 2 megahertz with a decimation of 1. And what that means is that when we activate the radio, we'll be listening to or capturing a section of the spectrum that's 2 megahertz wide, centered on whatever our center frequency is that's shown up here in the RX control. This button here controls whether the radio is on or off, so to speak, so I'm going to turn it on and then mute the audio just so I can better show what I mean about the bandwidth setting. So there you can hear the radio's receiving and getting some static, but again, I'm going to mute that for now. So you can see here from the spectrum display that our bandwidth right now that we're capturing is 2 megahertz, and it even tells us that down here in this information block. Our span is 2000 kilohertz or 2 megahertz. So if we want to change that, we have the option to do so by clicking on the button up here in the main window. And you can see we can choose between a few different presets, anywhere between 2 megahertz and 10 megahertz. Now what I've found is that on an older computer such as this, if we try and receive 10 megahertz worth of spectrum, it doesn't work real well. It draws a lot of power from the CPU of the computer, and the audio starts to cut in and out as the computer kind of deals with it. Let me turn the audio back on for a minute just so you guys can hear that. Okay, so you could probably hear it cutting in and out. Now again, a more powerful computer would have an easier time dealing with that 10 megahertz bandwidth. So what I found is that for most casual listening, I prefer to go to 2 or maybe 3 megahertz anyway. So we're going to go back to 2 megahertz, and I'll turn the audio back on briefly just so you can hear. And you can hear it's not cutting out, it's nice and smooth and working well. So even 2 megahertz can be kind of a wide spectrum. The computer can handle that, at least my computer can, but sometimes that's just a little bit too much. You don't want to see all that. You want to have a little bit finer resolution. And you can control that by the decimation control, which is here next to the spectrum resolution. So if we click on this, you can see that we can just choose from a few different preset numbers. So really what's happening is that the sample rate that we've chosen is divided by the decimation number, and that gives us a narrower bandwidth. So in this case, we're down to 500 kilohertz. And you can see that we're getting a little bit more resolution here on the spectrum display. We can see the spikes a little bit better and can maybe make a better decision as to what signal we want to listen to. Now I talked a little bit about CPU usage, and you can see here in the main window that there are 2 sort of fuel gauge bars, and these show the CPU usage. The bottom one shows the CPU usage of the PC, and the top one shows the CPU usage of the SDR. I found that keeping the CPU usage of the PC somewhere here in this sort of orange range is kind of best. Now mine's riding a little bit higher than it would normally because I've got my screen capture application running in the background, and that takes a little bit of the resource away. If that wasn't running, this would be a little bit lower, which means I could probably bump up the bandwidth if I wanted to and still have smooth audio. These 2 buttons here control the bandpass filters that are in the RSP1A. This one is a AM and FM broadcast bandpass filter, or maybe more accurately a notch filter, because what this does is it kind of attenuates the signals that are in the broadcast band to help prevent them from overloading signals that you may be trying to listen to that are not in those particular frequencies. And then there's another one here that does the same thing for the digital audio broadcast band. Now this is something that we don't really use here in the United States, but over in Europe and other parts of the world this is a very nice feature to have as well. Over here we have an RF gain control, and we can kind of slide this up and down to control the RF gain that we're getting. So for a weaker signal that you're trying to listen to, you might want to bump this up, but you can kind of see what's happening is that the higher you move the RF gain, the noise floor kind of goes up with it. And the lower you bring it down, the lower the noise floor goes. So what I've found in playing around with this current RSP1A and SDRuno is that I like to leave the RF gain down as low as I can, and then only bump it up when I need to pull out a weaker signal. So I'm going to leave it down at the lower setting. These 2 buttons up here are used for controlling multiple sessions of our SDRuno, or kind of like multiple virtual receivers. I'm not going to go through that in this video, so we'll just skip over those. Now that we have our basic bandwidth set, so to speak, and some of our basic options here, let's tune around and listen to some signals and go through some of the more detailed settings up here in the RX control. So there's a few different ways to tune signals in SDRuno. One of the ways that I prefer to do it is to go here to the main RX control, and in particular the frequency readout up here. And what I like to do is hover my pointer over the various registers and just use the scroll wheel to tune around and see what I can hear. So let me unmute the audio so we can hear what we're doing while we tune around. And as you can see, we are in the 80 meter ham band to start off. So let's stay there for now and see what we can hear. So I'm going to stay in the AM mode for now, as we've got some signals here that are transmitting in AM. You can see that that's controlled by this line of buttons under here. We can choose between AM, synchronous AM, FM, CW, double sideband, lower sideband, upper sideband, and digital modes. Again, let's stay in AM for now.
Which rig is that?
The scout driving the...
So now you can see here, down in the spectrum display, you can see the signal that we're listening to right here. And you can see that we're off frequency a little bit. So we can tune that in a little bit better by scrolling up to probably 3872, 3873, maybe 3875. That's about where it seems to be centered. Now you can see we're on that frequency. But now let me go back down to where we were and show you that the other way that we could center that is to just bring the pointer over here to the spectrum display, and we could just click on that signal peak right about there, and that'll automatically tune the radio to that frequency. Well, we're up a kilohertz, but we can bring that right back down with the scroll wheel. Now the other thing that you can see here is you can see this darker area indicates the passband. This is what we're currently listening to. Everything outside of that darker area is attenuated and we're not hearing it. But we can obviously see it here, and if we want to tune to it, we can simply just bring our mouse over and click on it. Now the other thing you can do is you can hold the pointer down and drag the slider if you want to do it that way too. But I'm going to go back up here to 3875 or thereabouts. So now let's take a look at the passband window, or the extended spectrum window, and look at what's going on over there. So because we're in AM mode, you can kind of see right here, this peak is probably the carrier of the signal that we're listening to. And then you can kind of see the audio sidebands on either side of the carrier. And they fit neatly within the current passband that we have set, which, according to the filter presets up here, is 11 kilohertz. And that's also verified by the information block here. So you can kind of see here from the spectrum display that some of these other stations, their signals are actually a little bit wider than what we're listening to currently. So if we want to change that, we can go over here to these filter presets and change from 11 kilohertz, say we want to go to 20 kilohertz. And you can see both here in the auxiliary spectrum and down here in the main spectrum, this is kind of widened out, and now we're covering the range of the whole spectrum that these guys are using. So, and effectively what that's going to do is that the more of the signal that we're receiving, the better it's going to sound. But at the same time, we could be picking up more noise by broadening that out. Now, if that were the case, if we were getting some noise somewhere in that bandpass, what we could do is narrow the filter up by choosing one of these narrower options. And you can probably hear that now these guys don't sound quite as good, but again, if there were noise on the signal somewhere, we could probably cut that noise out if we needed to. Another way to change our filter width is to go here to the auxiliary spectrum window, hover over one of the red lines, and then just click and drag it to as wide or as narrow as we want. So one thing I'll mention is that when we're in a mode like AM or FM, clicking and dragging on this will bring both sides of the filter in or out the same amount. If we switch over to another mode such as sideband, you can see that clicking and dragging that will only bring whichever one we're hovering over at the given moment. So let's find a sideband signal to listen to just so you guys can hear what that sounds like, and we can play with some of the settings that control that. So most of these other signals that are here in the 80 meter band are probably sideband, so I'm going to just go for one of these stronger ones here. Okay, so here's a sideband conversation that we can listen to. So you can see here that my filter is set at 2.8 kilohertz, and that seems to be passing most of the audio. We can widen it out to 3 kilohertz if we want. So now again, like I mentioned before, if we want to widen this out or narrow it up sort of in a custom manner instead of using the presets up here, we can just go down to the extended audio spectrum and just click and slide this around however we see fit. Now, one of the things that you may be able to see here in this signal and hear it, there was sort of somebody tuning up. There was a signal spike or a carrier right around here in this range. And that's what these notch filter settings over here are useful for filtering out. So I don't know if that's going to keep continuing to happen here as we listen to it, but I'll show the notch filter anyway, and just so you guys can see that. So there are 4 notch filters available that we can set, and then this last button down here locks the filters into following us as we tune around. So what I'm going to do is I'm going to activate the first notch filter, and then I'm going to come over here to the extended options window pane, and you can see up here at the top there are 4 blocks, and each one of these blocks correlate to the notch filter over here. So we're working with notch filter 1, so we're going to change these 2 fields. We can set the bandwidth by clicking in the box over here and then using the scroll wheel up or down to kind of change the width of the bandwidth of the notch. So I'll leave it there at 120 Hertz just for now. And now this frequency field controls where in the passband the notch filter is going to be. Now currently over here you can see this dotted blue line. This shows that our notch filter is currently out of the passband. And that's not really going to do a whole lot for us. So we're going to want to move that into the passband. So we got to go up here to the frequency field, and if I just click in here with the mouse, you can see that the frequency goes down by 100 Hertz each time I click it. And now you can see that this blue line is in our passband and our notch filter is working. So if I click down to about there, I think that's about where that signal spike was that we saw earlier. And so if that signal spike appeared again, we wouldn't hear it. And you can see from the spectrum display here that there's no signal being passed where that notch is placed. Okay, so what I'm going to do is turn the notch filter back off since we don't really need it right now. Okay, so let's talk about some of the other filters and features that we have here. And we're going to kind of have to go back and forth a little bit between the main RX control and the extended control options over here. So I guess the first thing that I'll talk about is the AGC. Now this works sort of like a regular AGC on a regular shortwave receiver. We've got fast, slow, and medium settings that we can toggle between. And then over here we can adjust the AGC level by clicking and dragging the slider. Now this only works when one of these AGC filters is set. If the AGC is off, this has no effect. Next up is the noise blanker, and this is useful for filtering out pulsing type noises, things like ignition noise or repetitive pulses, things like that. Anyhow, we can see that there is a narrow and a wide preset that we can choose from. And again, when one of these is on, we can come over here to this slider and slide it up and down to determine the amount of effect that that noise blanker will have. Over here we have a noise reduction. This is sort of like a DSP type noise reducer, and this will help kind of attenuate the background static using sort of a digital type algorithm to do that. So once we turn that on, we can slide the slider over here to adjust how much or how effective that noise reduction is. And you can see the further we go to the right, the more aggressive it gets. And again, just like the others, this is only effective when the option is turned on. Now here we have a CW peak filter that works about the same, and I'm not going to show that right now since we're not in CW mode. And then I'll just briefly mention that these settings down here control some of the FM broadcast settings and AFC and things like that. So these are really only applicable when we're listening to FM signals. So now down here in the extended audio spectrum and the main spectrum display for that matter, we have a bunch of options that we can change to control how this looks and feels. So to access those settings, we can go over here to the settings button, and you can see it brings up this window, and we can kind of just fool around with all of these and just see what they do. The FFT option controls how the spectrum peaks are kind of displayed, and you can see that if we change these, the way that the spectrum displays is slightly different. It's kind of a subtle difference, so I'm just going to leave that on the default. Next up over here, we can change the color palette of the waterfall by choosing one of these options. So if I go to WinRAD, you can see that we get a little bit different look down here in the waterfall. Over here we can change the FFT averaging. So what this does is that the higher the number you choose, it kind of slows down the spectrum display. You can kind of see that the peaks are now moving slower, so to speak. So depending on your preference, you can set that however slow or fast you like. I'm going to put mine at 5. That seems to work good for me. Over here, this option allows us to instantiate a timestamp marker. You can kind of see down here in the waterfall display that these timelines show up now. This is useful if you're trying to track a signal that's at certain intervals or something like that. You can kind of time it and see where it shows up. I'm going to leave that off for now. And you can change that time interval by choosing one of the options here. You can see one puts a timeline at every second, and we can go all the way up to 1800 seconds. So I'm going to change this back to 5 and disable it since we don't really need it for this demo. Over here we can change this slider to change the gain of the waterfall display, and you can see as I slide it to the right, all the various representations of the signal peaks get brighter. And we can also play with the contrast. We can slide this up and down, and you can see that the further to the left I go, sort of the less contrast we get, and the further to the right, the more contrast we get. This slider controls the spectrum range of the spectrum display. You can see what happens as I slide this to the right. You can see that the spectrum display gets a little bit finer, and we can see a little bit more detail and resolution. And we'll kind of leave it like that. And then this slider over here controls sort of where that base is. You can see the decibel ratings over here on the left. And what I usually like to do is just kind of put this about where the noise floor is of the signals that I'm listening to. And then we can kind of slide this up to zoom in a little bit more. And like I said, that gives us a little finer detail look at what the signals are that we're looking at. This option but down here slows our time down by a factor of 100. You can kind of see it looks like everything's frozen, but there it just changed a little bit. And if I wait long enough, it'll change again. So I'm going to put that off. And once it gets back, it reactivates. This turns off the FFT when closed. This toggle here changes whether or not the spectrum display is filled in or not. You can kind of see the difference there. This toggle here changes whether or not the S meter and signal strength information is displayed or not. This toggle changes the waterfall over to an averaging mode, and you can see what that does is that kind of smooths things out. Before we turned that on, all of the peaks were kind of represented as almost individual pixels, and here you can kind of see how it's smoothed out and averaged. This toggle here just simply changes the direction of the waterfall. If you'd like it going up rather than going down, you can turn that on, or if you like the traditional view, you can turn it off and let it go down. Now this combo transparency here doesn't do anything in the current display mode that we have, but if I go down here to the lower left of the spectrum display, you can see there are 4 buttons. There is a button to display the spectrum only, or the waterfall only, or the spectrum and waterfall together, which is the default and what we've been looking at. Or we can change this over to combo, and we can see the spectrum and the waterfall together on the same display. And this combo transparency, as you can see, as I slide it around, it just changes the transparency of what we're seeing in the combo display. This last toggle controls whether or not the frequency is shown next to the cursor when we're in the spectrum display. You can kind of see as I slide around, the frequency and the signal strength is displayed just to the right of the cursor. If I turn that off, that information goes away and we see just the cursor. Most of the options and settings that are available down here in the main spectrum display are also available in the auxiliary spectrum and can be accessed by clicking the settings button up here in the top left of the auxiliary spectrum. So while we're looking at the auxiliary spectrum, I'll show this button here, this F button, turns on the entire frequency display across what we're seeing in the whole spectrum window. And if we turn it off, we only see what's coming through the passband, or where the red lines are. And then down here, just similar to the main spectrum display, we can look at just the spectrum, just the waterfall, or both of them together. One thing I almost forgot to mention, there is a zoom control on both the main spectrum and the auxiliary spectrum. And we can use this to kind of zoom in and have a closer look at what we're looking at, so to speak. You can see that when I click it, the resolution gets finer without changing our current sample rate or decimation. Alright, so I think that covers most of the basic controls and settings that we need to tune around and do some casual listening. So, having said that, let's do just that. Let's tune around some of the bands, see what we can hear. If there's any settings or controls that I missed earlier, we'll cover those as we need them. So up to this point, we've been mostly listening to the 75 and 80 meter ham band. But let's take a look down at the AM broadcast band here and tune around to a few stations and see what they sound like. So you can see I've tuned down to 1080 WTIC out of Hartford, Connecticut. That's my favorite and probably closest AM broadcast station. And of course we've also gone over to the AM mode. And I've got my filter set at 20K. That may be a little bit wide, but let's unmute the audio and see what it sounds like.
If it's easier to text, you can do that as well. Just be sure to include your first and last name. Either way, we'll get back in touch. We're talking about the 8 essential questions you must answer before you can retire, or if you're already retired, the 8 questions that you absolutely should have answered already.
So that sounds pretty good. But you can kind of hear a little bit of noise at the fringes of the signal, and we can even kind of see them over here in the auxiliary band scope. There's a little something going on. So let's narrow that up to 11K. And you can hear we lose a little bit of the spectrum, but we get rid of that kind of high-pitched noise that we're hearing at the edges. So this may be a little bit easier to listen to.
We'll reveal the second half of our list here of the 8 essential questions you must answer. Number 5 on the list, Joel, is what is your appetite for risk, and how well does your portfolio reflect that?
So let's tune around a little bit. I'm going to use my scroll wheel method up here in the main RX window and just kind of go through the AM broadcast band and see what we can hear. Okay, actually before we go through the AM broadcast band, I'm going to scroll down below the AM broadcast band and demonstrate this filter that's been added to the RSP1A so you can hear what it does. So we're down here around 470 kilohertz or so, and you can see there's a bunch of signals down here. Now, there really shouldn't be. There's not a lot going on down here, but what you'll hear when I unmute the audio is that these signals are actually images of the broadcast band. So you can hear there's quite a bit going on down here. It's pretty much overloaded. But if I go over here to the main control window and I click on the medium wave and FM filter, you can hear that it attenuates all of that. And now what we should be left with are real signals. So you can hear that over here in the AM broadcast band at 560, we're still hearing one of the local louder stations coming through even with that attenuator on. But down below the broadcast band, most of those images that we were getting are pretty much gone now. So if you were interested in trying to listen to signals down here, you'd definitely want to turn that on, especially if using an outdoor very sensitive antenna like what I have. But I'm going to turn this off and we'll go back up through the AM broadcast band and hear what we can hear.
Again, you know, when you live in Maine and you're a snowbird.
Okay, so here's 560 AM, WHYN out of Springfield, Massachusetts. The station's not that far away. I'd say the transmit location is about 25 or 30 miles, maybe about the same distance as WTIC is from here.
Moisten them. I don't know if anyone has things that we use to moisten clothes.
Okay, here's 580 WTAG out of Worcester, Massachusetts. This is probably 35 or 40 miles to my northeast.
At all, but we don't want them to shrivel into.
But they don't do that, and they're teaching children that our founders were a bunch of racist old white guys.
Okay, here's a weaker station. This is W830. I think that this is WCRN out of Worcester, Massachusetts. This would be 35 or 40 miles to my northeast.
CEO of MGEMI, a luxury shoe
Here's 1010 Winds, WNNZ, out of New York City. And that is, I don't know, 80 or 100 miles southwest of me or so.
online and has it shipped to your home.
They've done a pretty good job of learning through our data.
It's open all year long.
Oh, I agree. And so
Here's WBZ 1030 out of Boston. This is probably 60 or 70 miles to my northeast.
Think that they have anything to do with the garden. This is a way for us to help you enjoy what we've got going on here.
Caregiving Resource Center at AARP.
Here's 1130 WBBR Bloomberg Radio out of New York City. Again, 80 to 100 miles or so to my southwest.
AARP and the Ad Council.
My husband and I absolutely love our home.
Here's 1250 WARE out of Ware, or maybe it's Warren, Massachusetts. I think the transmitters are actually in Warren. This is probably about 20 miles or so due north of my location here in northern Connecticut. Here's 1360 WDRC out of Hartford, Connecticut. This is one of the closer stations to me, but it is a lower power station, so it's not coming in quite as good as some of the other ones are. I think this one's only about 15 or so miles to my west-southwest. Okay, that's probably a pretty representative sample of the AM broadcast band on a Saturday morning here in northern Connecticut on the RSP1A. Let's find something else to listen to now. Okay, so we got a station here out of Croatia. He's pretty strong, but you may be able to hear there's a little bit of interference from an adjacent station coming in. So let's see what we can do to filter that out. I'm going to zoom in a bit on the spectrum just so we can kind of see what's going on. Then I'm going to go into the settings and I'm going to raise the spectrum base up a little bit so we can see the noise floor again. So if we take a look at the spectrum display, and you can see it a little bit here, there is another signal that's sort of down here. So if we click and drag this filter line, we should be able to get rid of that signal by kind of bringing it right about there. And now we should be able to just focus on the signal that we're interested in, the signal from Croatia. I think what I'm going to do now is go up to the 17 meter band, and the way I'm going to achieve that is over here in the right hand side of the main RX control. I can just click on the 17 meter band button, and that'll just bring us into the 17 meter band. So now you can see there's a signal over here that we may be able to get, so I'm just going to bring my cursor over and click on it. And there it is.
Report next time here on the band. Oscar Echo 8, Tango Lima Kilo from K1 Italy. Go ahead.
So let's go up to 6 meters now and listen to a couple of stronger local stations. These guys are actually friends of mine, and they've agreed to be in the video here. But what this will demonstrate is a nice, strong signal with a nice low noise level.
You're just itching to buy a radio.
No, not really. You know, like I said, if I was going to spend a lot of money, but the thing is, though, I don't consider that spending a whole ton of money. I don't know. Not a bad radio. No, I'm trying to suppress the urge because I do not need another radio. I have this radio, the 1200 that I bought 2 years ago. I think I would like a 7300 a little bit more, but this is a nice radio, and I've got the Pro 2, which is not getting terribly long in the tooth. That radio will probably last me a long time, so I don't really need one. And as far as spending radio money, I have a blast just going to Deerfield and Boxborough and stuff and coming home with goodies to play around with.
There's a guy up on 495 who's advertising a 790 on Craigslist. I've seen him advertised before, and obviously he didn't sell it. But he's got the 790 with tone boards for both 440 and 2 meters. The matching Kenwood speaker and the power supply for 725.
Okay, so now let's try listening in on some FM signals up in the 2 meter band. So again, I'm going to go over here to the RX panel and hit the 2 meter button. Sometimes you'll notice that when you change bands, the sample rate and the decimation will change. So I'm going to back this back down to 2 megahertz, and I'll put the decimation back at 4, just so that we don't have any audio skipping. And let's tune around the 2 meter band and see if we can hear anything there. Looks like we've got a couple of repeaters or something over here. Now it looks like that one's off. Let's try this one.
Without the 6 meters? About the same, maybe a pinch, but...
So I believe this is the Donkey Dusters Radio Club. I forget the call sign of this repeater, but I believe it's transmitting out of East Hampton, Connecticut, which is 20 or so miles south of here. And keep in mind, we're receiving this on my 80 and 40 meter fan dipole. This is not a 2 meter only or 2 meter specific antenna that we're receiving this on, so signal is pretty good for that. Okay, well, I guess those guys have signed off. Not a whole lot going on the 2 meter band here on a Saturday morning. We're here in the local NOAA Weather band, and you can see there's several stations that we can see here. The strongest one being, what is it, WXJ 41? Or maybe it's 42, I'm not sure. I know that this one is located on Soapstone Mountain, which is only a few miles from my location. That's why it's so strong. I'm not sure where the others are, but it looks like we can hear them all. So let's give them a try. Let's tune around and see what they sound like.
9. Sunrise today is at 7 a.m. and sunset is at 4:20 p.m. Now for the official National Weather Service forecast for northern Connecticut and southwest Massachusetts, including Hartford and Springfield. Showers in the evening. Then
okay, so here's a station down at 162.400. Not sure where this one is.
Chance of precipitation 30%. Thursday, partly sunny. Highs in the lower 40s.
So now that this one's a little stronger, I'm going to open up this pass band a little bit.
1873. Here are the 9 a.m. reports from around New England. In New Hampshire, at Manchester, it was cloudy. The temperature was 32 degrees. The dew point 26, giving a relative. In Jaffrey, cloudy. Temperature 30.
Okay, so there's another one here at 162.550. This one's fairly strong. Not sure, again, where this one is. I'll have to look all these up. But you can kind of get an idea of what things sound like on FM.
Once again, repeating the 9 a.m. weather for the Worcester area. It was sunny. The temperature was 34 and the wind was north at 6.
Okay, now that we've looked at some narrow FM signals, let's take a look at some wideband FM signals that we would find on the broadcast band. So right now I've tuned to 91.7 WHUS. That is the local radio station for the University of Connecticut. It's probably the closest FM broadcast station to me. And you can see here I've got the sample rate still at 2 megahertz with a decimation of 4. And that gives us sort of a narrow snapshot of this band because the signals are so wide. So what I'm going to do is move that up to a 1 decimation factor so that we can see some signals. And the other thing that I've done is I've set my filter up here to the super wide FM setting. That gives us a bandwidth of 192 kilohertz, which is what we need to receive a typical FM broadcast station. So let's turn the audio on and see what it sounds like.
hammers with Bud Light and Rock 102 Springfield.
Restaurant in Rhode Island for the last
$4.99 a pair, $20 to $30 scarves, and priced right at Ocean State Job Lot.
It's a marketer's dream to connect with as many people.
It's beginning to look a lot like Christmas. I've been lost by love. There's a kind of thing that just breaks a man.
That's pretty much going to wrap up the basic setup and operation of the RSP1A from SDRplay. If you'd like to learn more about any of SDRplay's products, including the RSP1A, be sure to check out their website at www.sdrplay.com. You'll find a link to it in the description below. You'll also find some videos I made covering the setup and operation of the older RSP1 from SDRplay in my channel archives. I'll leave links to those videos below, as well as thumbnails to a playlist at the end of this video. If you enjoyed this video, please give it a thumbs up. And if you'd like to leave a comment or subscribe, feel free to do that as well. Thanks for watching.